Hi friends, welcome on YourPedia, and this video is related to Micromodule of Airport Authority of India exam, which is going to come on 14th July 2025. The way to prepare now is totally different. The way to prepare smartly is totally different. We have previous year's questions, we analyze previous year's questions, and we understand the learning content of those questions, and we practice similar questions. Three stages, three steps of preparation. When 15 days are left for exam, all you should do is lot of practice of such questions which can help you to get really good score. Now those of you who acquire this skill, those of you who do this, follow this strategy, will score good. Those of you who will not do it obviously will lack, and may not get good score. As far as Airport Authority and ATC exam is concerned, many of my interactions, if you see on YouTube channel, you will find that students have cleared this exam by practicing lot of questions last 15 days. That is very important. Here YourPedia is offering you the micro module, which is nothing but the most important questions which you should practice last 15 days. And I can assure you that the mentors are going to provide you the best content, best learning. Now this video is related to modern physics. In modern physics also, couple of questions, previous year's questions, they have been taken what couple of questions? 19 questions in previous couple of years, I think 2020 onward. Past 5 years may whatever questions from this part have come. Modern physics is quite big, but this part of modern physics, I'll be covering modern physics in 3 or 4 such lectures. So I'm giving you 19 previous year's questions, concept behind those questions, and the practice plus learning content. From my perspective, you should complete this document in 2 hours. If you do that in 2 hours, believe me, you can cover up entire syllabus of Airport Authority of India. So let's start without wasting time, friends. In case you have not so far taken the micro module of YourPedia, you have to call this number, or you have to join the micro module. You have to take the micro module from the link which is given with my video. So this is the micro module for modern physics, and in the modern physics also I'll be covering this in 3 to 4 lectures, this kind of lectures. Now this particular modern physics is related to electromagnetic rays. We know couple of rays like radio waves. Radio waves are also FM, AM, infrared, and this diagram is giving you some idea. There are so many such diagrams. All you need to remember is like which of the electromagnetic rays or waves have highest wavelength. As you keep on going in this direction, then what happens to the wavelength, what happens to the frequency, those kind of things you have to understand. So you see the frequency is high, wavelength is more. Understand what is the meaning of wavelength? Wavelength means this to this. So if I give this peak and I take another peak, the difference between one peak to another peak or one trough to another trough, that is called wavelength. So as you can see, wavelength here is very less, so frequency is more, and E is equal to h into nu, Planck's constant. Nu is the frequency. Higher the frequency, higher the energy. So one side is gamma ray, very high frequency, high energy. Another side is high wavelength like AM, radio. So you need to remember this. What is the frequency, what is the energy level, and visible range is from violet to red, ultraviolet, infrared. One side is ultraviolet, another side is infrared. So this is all we are going to discuss. I'm not going to teach you, friends. So these are the previous year's questions from this particular part. Go through the previous year's question, go through the learning behind these previous year's questions. So this entire document is made in such a way that previous year's questions, what is the concept behind that, what is the learning content, and more practice question. Now arrange in the ascending order of the wavelength. So he has given you electromagnetic waves, and some ascending order as per the wavelength is to be done. So this is the answer for that. So remember, this is the table given to you. So these are the previous year's questions. So what is the wavelength range? Like gamma rays, as you keep on moving, the wavelength increases. So some idea about the wavelength you should have. So shorter wavelength like gamma and X-ray. So minimum wavelength is of gamma, highest frequency is of gamma. Gamma rays are very energetic, X-rays are very energetic. Energy level is very high, so this can pierce through your body also. So then longer wavelength. So this is something which you have to learn. And couple of diagrams which I am providing you. Frequency, as I told you, gamma rays have very high frequency, you know, 10⁻²4 hertz. Then this ultraviolet range, what is the ultraviolet range of frequency and wavelength, that also you should know. And then we have wavelength. This side is frequency is increasing, so this high frequency, high wavelength. What is the frequency, what is the wavelength? So you should have some idea about this. Right, so some values you need to know. Second question, photon is associated जो photon is the packet of energy. So energy, obviously energy is nothing but, as I told you, this is the violet is one side, red is another side. Red is one side, violet is another side. You see, red is this side, violet is this side. Where the frequency is more, violet has more frequency. If violet has more frequency, so what do you think is the answer? Violet has more frequency, it has more energy. E is the energy of the photon, H is the Planck's constant. You should know the value of Planck's constant. Frequency you should know, speed of light, wavelength. So because violet has maximum frequency, so hence the energy of the violet is very high. Violet, green, yellow, red. This is how frequency and this is increasing. So infrared waves are produced by what? So production of these radiations and the rays, how these rays and radiations are produced, that also is the question. So how these rays and radiations are produced, that is another question. Yeah, so infrared comes between visible light and microwave, you know. So hot bodies and vibrating molecules will release, that is the information now. So if the body has a temperature above zero, absolute zero temperature cannot be there, that is the third law of thermodynamics, then infrared radiations are released. Like whenever the body is having some temperature or thermal energy, it radiates the infrared radiations, right? Molecular vibration and rotational transition. So infrared radiations are produced by hot bodies and the molecules, right? So whenever there is a temperature, infrared radiations are released by hot bodies. That is what you should know. Right, now let's say lambda 1, lambda 2, everything wavelength is given. Again the same question. You see the questions are being repeated from the same concept. So all you need to know is the diagram which I have shown you, and many more diagrams I am going to show you. Gamma has maximum frequency, minimum wavelength. So here wavelength you are increasing from gamma to microwaves. Increasing wavelength, increasing frequency. Stop your video here and memorize these things. Though you have the document, YourPedia has given you a document, please revise this document and you will understand the meaning of it. And for God's sake, take these documents, because questions are going to come from here directly in the exam. Okay, so again, first is correct, because whenever the temperature 0 Kelvin, absolute temperature cannot be attained. Absolute temperature cannot be attained. Who says that? 0 Kelvin cannot be attained. This is the third law of thermodynamics. You know how many laws are there in thermodynamics? There are 4 laws, including 0th law, first law, second law and third law. Third law of thermodynamics says 0 Kelvin temperature cannot be attained. Whenever there is a molecule or atomic motion, vibrational motion, then this is what is happening. Second statement is also correct. Ultraviolet radiation. You must have heard that ozone layer in the stratosphere, ozone layer protects human being from the ultraviolet radiation of the sun. So ultraviolet radiations are emitted by sun, and those ultraviolet radiations then are converted into infrared radiations, right, once they come through ozone. So ozone protect us from the harmful ultraviolet. And why ultraviolet are harmful? Because these are more energetic than infrared, more piercing the body, and it can kill the tissues in the body and create the cancer, on the skin cancer. That is the ultraviolet. Minimum wavelength, again the same question. I think there is nothing in this to be done, same questions and same concept. Maximum energy, right? Maximum wavelength, maximum frequency. So radio has what? Radio has maximum wavelength. Gamma has what? Maximum frequency, and energy is proportional to frequency. So maximum frequency, maximum harmful. So ultraviolet more harmful. Ultraviolet is more harmful compared to infrared. That is what you should know. Okay, now de Broglie hypothesis. Lambda wavelength is h over mv, velocity of the particle. If the mass is more, then wavelength will be small. On the basis of this concept, question is asked. So in Airport Authority of India, you are not to revise entire physics. In fact, you are not to even revise 10% of the physics compared to exams like NEET. Forget about JEE. NEET में जो physics आता है, the physics in NEET, उसका भी 10% only is Airport Authority of India. Very simple questions like this concept. Now this is the concept. We have done another concept. Now this is another concept. Wavelength, de Broglie wavelength, Planck's constant, mass of the particle, and this is the formula. How do you calculate is this? Now, what are the mass of electron, proton, neutron, alpha particle? Alpha has maximum mass, electron has minimum mass, and followed by proton and neutron. So electron, proton, neutron, alpha. Increasing mass, remember it. Increasing mass. So if mass is increasing and mass is inversely proportional to wavelength. Okay, deflection of rays. Electromagnetic radiations are not particle. They are the packets of energy with zero mass and no charge. What are the electromagnetic radiation? They are the photons. What is photon? Packet of energy. Packet of energy with zero mass and no charge. These packet of energy do not have any mass and they do not have any charge on that. Zero mass and no charge. Electric field, magnetic field, electromagnetic field, no impact, no effect. X-rays are electromagnetic waves. These have no charge and these are not charged particles. Alpha particles, beta particles. Alpha and beta particles are charged particles. Alpha is helium 2+. You have seen that alpha particles is positively charged. Are these affected by electromagnetic waves? Both electric and magnetic field, yes. Beta, yes. Gamma or X-rays, no. So it's very, very important. Alpha particles, beta particles, proton, all get, these particles will get deflected because these have charges, but these X-ray, gamma rays, they will not be deflected. Okay, this question already we did. Okay. Okay, so 1 and 4 are correct, not correct, not correct. So 1 and 4 are not correct, 2 and 3 are correct. Okay. So infrared radiations, global warming, you people must be knowing. Global warming, greenhouse effect. Greenhouse effect में, global warming greenhouse effect में infrared plays very, very important role. The surface of earth, these radiations, infrared radiations ultraviolet radiation from sun get convert into infrared. When it passes through ozone, infrared radiations fall on the surface of earth, lead to global warming or greenhouse effect. So global warming or greenhouse gas effect is because of this. Some LEDs like Gercium arsenide, if I am not wrong, based diodes emit infrared radiations. टीवी रिमोट सेंसर्स में आप इसको यूज करते हो, तो जब टीवी वगैरह में रिमोट में आप यूज करते हो, दैट इज इंफ्रारेड रेडिएशंस ओनली. वाटर वेपर इज ऑल्सो वन ऑफ द ग्रीन हाउस गैसेस. सो वाटर वेपर इज ऑल्सो वन ऑफ द ग्रीन हाउस गैसेस. So thermal motion will increase because infrared radiation will give you energy. So it does not decrease but it increases. Okay, so gamma rays, X-rays, ultraviolet radiations, when they are moving through vacuum, these move with same speed but different wavelength. They have different wavelengths. What kind of electromagnetic waves these are? Electromagnetic waves move with the same speed of light, different wavelength but same speed of light. This is the value you need to remember. C is the speed, so speed is same and wavelength of ultraviolet is more than, so gamma has minimum wavelength, maximum frequency, maximum energy, and energy is related to E is equal to Planck's constant into frequency. So higher the energy, higher the frequency, higher is the energy. So now start making some sense of these electromagnetic radiations. As I told you, this document is self-explanatory, friends. Now de Broglie says lambda is equal to h over mv. P means mv. This is the momentum. Another equation you should remember is this, very very important equation. So P square by 2m is the kinetic energy. So E is equal to P square by 2m. P is the momentum. So P momentum, if you want to calculate, 2 into E into m, something like that you can. E is the energy, right? So lambda is equal to h over p. This is momentum of the particle. This is how they are related. These two formulas you please remember. Now lambda, if you see, is inversely proportional to under root of m. So he says that same kinetic energy. Now we need to keep E as constant. So this is the formula. Then this is the kinetic energy. Kinetic energy is to be kept same. So lambda is equal to h over p. Instead of p, I put this. H is constant, right? Kinetic energy is constant, so it is inversely proportional to, it's a good question, under root of mass, inversely proportional to under root of mass. So if kinetic energy is same, then this formula is to be done. The mass of electron, proton, neutron you should know, and alpha particle also. For same kinetic energy, alpha particle has shortest de Broglie wavelength. So what is the frequency of ultrasonic waves? Normal human hearing range is 20 Hz to 20 kilohertz. Remember, this value is very very important, and ultrasonic waves have frequency more than 20 kilohertz. Right, so normal human range is 20 Hz to 20 kilohertz. Ultrasonic waves have more than 20 kilohertz. Okay, so how can you detect different waves? Because ultrasonic ultrasonic, more than sonic frequency, that is greater than 20 kilohertz. Human ear cannot detect. Special devices are required to detect these. What are those special devices? Piezoelectric detectors, quartz, Rochelle salt, electric voltage. Whenever there is a mechanical stress, अगर आप mechanical pressure, mechanical force लगाओगे, then some kind of electro EMF is produced, like electromotive force is produced. Piezoelectric materials are like that. So you produce some kind of deflection or compression in piezoelectric materials, electric current is generated. So this property is used in ultrasonic transducers to generate ultrasonic waves. When the crystal is compressed. X-rays are used to study the internal atomic structure of crystals. Reason, wavelength of X-ray is comparable to interatomic distance, that is also the same. So interference and diffraction is the technique through which it is done. So atomic structure of the crystal is analyzed using X-ray. What is the main reason for that? The main reason is the wavelength should be comparable to the interatomic distance. One atom, another atom, what is the difference? And that should be comparable to the wavelength of the wave, then only you get the interference and diffraction pattern. You study that in optics. So this is very, very important. Interference and diffraction within crystal lattice, and this is very, very important, Bragg's law. So Bragg's law formula, please remember, X-ray crystallography. It is called X-ray crystallography. Wavelength of X-ray, interplanar spacing in the crystal, so this should be comparable. So 2d sin theta is equal to n lambda. D is the distance between the atoms. Theta is this angle. It should be equal to n lambda. So to get this kind of pattern, Bragg's law is this. Very, very important. Question can come from Bragg's law. Okay, now this formula, friends, energy is hc by lambda or hf. H value, please remember, value of speed of light you should remember, Planck's constant, joule second. 1 electron volt is equal to this much of joule energy. H value, C value, and 1 electron volt or energy is hc by lambda. So he has given you 5000 volt, 50,000 volt potential. तो इलेक्ट्रॉन वोल्ट पोटेंशियल को एनर्जी में कैसे कन्वर्ट करेंगे? E इंटू वी करेंगे आप. हाउ विल यू कन्वर्ट दिस? सो एनर्जी इज इक्वल टू चार्ज ऑन इलेक्ट्रॉन इंटू वोल्टेज. वोल्टेज आपको दे रखा है चार्ज 1.6 इंटू 10⁻⁻19. या आप कर देंगे 1 इलेक्ट्रॉन वोल्ट इज इक्वल टू हाउ मच. तो फिर उसके बाद आप किस तरीके से उसको एनर्जी कन्वर्ट कर सकते हैं? 1 इलेक्ट्रॉन वोल्ट इज दिस मच जूल. 1.6 इंटू 10⁻⁻, दिस इज चार्ज ऑन इलेक्ट्रॉन ऑल्सो. सो 1 इलेक्ट्रॉन वोल्ट, charge on electron is in coulomb, 1.6 into 10⁻⁻19 coulomb. So 1 electron volt is equal to 1.6 into 10⁻⁻19 coulomb into volt. Coulomb into volt, charge into voltage is nothing but joule. So 50,000. Angstrom is 10⁻11. Picometer 10, you know, this. (10⁻19). So how microwaves are produced? Keystone valve. ये याद कर लेना, this is a data. And where microwaves are used? रेडियो वेव्स, माइक्रोवेव्स कहाँ यूज करते हो? इसका नीचे लर्निंग कंटेंट मैंने आपको प्रोवाइड किया है. ओके, सो आप पहले तो 20 इलेक्ट्रॉन वोल्ट की एनर्जी निकाल लें एंड यू कैन फाइंड इट आउट ऑन द स्पेक्ट्रम. थोड़ा सा याद भी कर लेना कितने इलेक्ट्रॉन वोल्ट की एनर्जी का है रेंज. दिस 10⁻⁵ 10⁻⁵ से 10⁻³ so 10⁻⁵, this is radio wave minimum energy, maximum wavelength. Radio waves have minimum energy and gamma rays have maximum energy. 10⁻⁵ electron volt to 10⁻³ then 3 to 100 electron volt. So ऐसे एनर्जी आपकी बढ़ती चली जाती है. एनर्जी इज कैलकुलेटेड इन इलेक्ट्रॉन वोल्ट. 1 इलेक्ट्रॉन वोल्ट इज हाउ मच जूल, आई टोल्ड यू. तो ऐसे एनर्जी बढ़ती जाती है, इसको याद कर लेना. सो एनर्जी कैसे है उसको याद कर लेना. 20 इलेक्ट्रॉन वोल्ट कहां पे लाई करता है? सो अल्ट्रावायलेट. सो ये याद कर लेना, वेरी इंपॉर्टेंट टेबल फ्रेंड्स, प्लीज रिमेंबर दिस. ऑलरेडी वी हैव डन इट. अब ये मैं आपको लर्निंग कंटेंट दे रहा हूं, जितना भी हमने ऊपर क्वेश्चंस किए उन सारों का लर्निंग कंटेंट. वेवलेंथ, फ्रीक्वेंसी, एनर्जी ऑफ डिफरेंट वेव्स, ये देखना पड़ेगा आपको. निमोनिक कैसे याद करें इसको? ग्रेट जीलोफोन अंडर वेरी इंटेंस म्यूजिकल राइम. आई मीन जरूरत पड़ती है आपको तो याद कर लेना, अदरवाइज यू कैन अदरवाइज ऑल्सो रिमेंबर. इट इज नॉट वेरी डिफिकल्ट दैट गामा मैक्सिमम एनर्जी followed by X-ray minimum energy of AM radio wave and then FM radio wave. So this is nothing difficult. Gamma, great. X-ray, maximum energy, maximum frequency, minimum wavelength. Then keeps on increasing. Radio wave may be AM waves. Some more information about these waves. Infrared means heat energy. These all details friends are provided to you. Types of electromagnetic radiation and their application. Gamma rays where you are using, X-rays where you are using. Gamma rays are used in the medicine to kill the cancer cells. Very detailed diagram. वेवलेंथ से लेके फ्रीक्वेंसी से लेके सब कुछ दे रखा है इसमें. इंफ्रारेड वेव्स, व्हाट यू शुड नो अबाउट दैट, हाउ दीज आर प्रोड्यूस्ड, हीट रेडिएशन, हॉट ऑब्जेक्ट्स, सोर्स ऑफ डिफरेंट रेडिएशंस. स्टीफन बोल्ट्जमैन्स लॉ बाकी जगह भी करेंगे बट दिस इज वेरी वेरी इंपॉर्टेंट. Special vacuum tube produce X-ray or electron beam, accelerated charge in wire, radio wave, special lamp, infrared because of heating. Real life application of infrared radiations, remote control में यूज होता है. डी ब्रॉगली वेवलेंथ, इसका भी मैंने आपसे डिस्कस किया. अगर काइनेटिक एनर्जी कांस्टेंट है तो √m आ जाएगा. वी हैव डिस्कस दिस. Electron, proton, alpha particles are deflected, neutron is neutral, photon, these are not deflected. Very very important slide, very very important table. Bragg's law, internal atomic structure of crystal, but X-ray is used because the wavelength of X-ray is comparable to the size of interatomic distance. This is the formula. This is the application of Bragg's law. How different electromagnetic waves are produced? Radio wave, methodology to produce, and where is the application? Microwave, how these are produced and applications. Similarly, infrared radiation, how these are produced, what is the wavelength. So last couple of these tables are very very important. Everything is covered. Ultraviolet, similarly X-ray and then gamma rays, and then last में this is a summary how these are produced. Then practice questions I am giving you on the similar lines, friends. I am giving you these 50 questions, and these 50 questions will be you will get in this particular table, and just revise these 50 questions, and I am very sure if you do this kind of 20 practices, I mean you will get an edge compared to your friends in your upcoming exam of Airport Authority of India. Join YourPedia, surely it will help you. Thank you.